Good morning, everyone. This is one more session on Linux system programming. In this session, we need to conclude the concept of libraries, and we need to start with another concept called operating system concepts with Linux environment. Before that, if my voice is clear and able to see the screen properly, please type 1. If my voice is clear, M8, now is it okay? M8, now is it okay? Okay, so if you're able to recollect what we discussed in the last lecture, we're trying to understand a very important concept called runtime linking mechanism. In the last lecture, we're trying to understand the concept called runtime linking mechanism. What is the dynamic runtime linking? And what is the procedure to achieve the dynamic runtime linking? 8 is saying that voice is low, but I increase the volume. Echo is coming? Is it the echo is coming? Just a minute. Now? Now? Okay. Okay. So in the last lecture, we are trying to understand runtime linking or runtime binding. So when one function is calling other function, suppose main is calling the sum function, the discussion is when this main function knows where exactly the sum function is there, means when the address is resolved, is the discussion. So there may be a three type of address resolutions. One is a compile time, means compile time only when you type ccp1.c only, this function will get the function that is called as a compile time binding. Second is load time, means when you write /a.out enter button, then at that time the calling function will get the address of the called function. Load time. Third one is a runtime. Runtime means there is a separate mechanism we need to achieve, we need to do for achieving the runtime binding. The advantage of runtime binding is whenever my program is loaded, the advantage of runtime binding is whenever my program is loaded, all the libraries are not going to be loaded. Whatever the dependency.so files are there, whatever our own created .so files are there, those .so files are not going to be loaded. Only my executable file is loaded into the RAM for execution. And at runtime, depends upon your program execution, we can make a decision which library you want, and that library function address you can get it at runtime, and you can call the function. If you don't want that library, you can unload it also. So for that, it is not a normal process. For that, you need to go for a different way of writing the program. For that, we need to use the functions called dlopen, dlsim, dlerror, and dlclose. Dlopen is useful for opening the dynamic library. dlerror is useful for displaying the proper error message, and dlclose is useful for closing the library, and dlsim is useful for getting the symbol address from that library. And what are the prototypes we are trying to understand? And whenever you are using these functions, which header file you need to use? Whenever we are using this function, which header file we need to use? dlfcn.h header file we need to use. And whenever we are calling this function, so we need to compile our program in a different way. cc p1.c hyphen ldl option we need to use. Why? Because if you don't use ldl option, when you compile the program like this, in this way, So in this program, we are calling the DL open, DL sim, DL error functions, but those function definitions are not present in a default three libraries. Whatever the linker is going to link, default the three libraries, whatever the linker is going to link. So this is some external library. So that is the reason you need to use hyphen LDL. And in the DL open, we are trying to understand the arguments of DL open. Uh, Return type of DL open we are trying to understand. This is a normal program. Just a minute. This is the program. DL open is a one function, and where I need to supply the path and library. Second argument is a flag. I am using the flag called RTLD lazy. The meaning is when you open a library, it will not directly go to the RAM, it will go to the virtual memory, and a little bit more effective use of RAM in this case. And upon success, DL open returns a void pointer. Upon failure, it will return a 0. If it is failed, I am checking the condition and I am printing the error message, proper error message. And after that, as you know that these lines will execute only these lines will execute when option is 1. And also you know that option is 1 or 2 or 3 when it is decided. And also you know that option is 1 or 2 or 3 when it is decided. Will you agree it is decided at runtime? And once we open a library, we will get the entire library address here. Once we open a library, we will get the entire library address here. In that library, there may be so many. In that library, there may be so many functions. So if want to know, if want to get that function address, we need to take the help of DLSIM. DLSIM first argument is the DLSIM first argument is this handler, and the second argument is the function name, which function address you want, and that should be what you called in a string. And DLSIM returns the upon success it will return the some function address. Upon failure it will return a 0. If it is a 0, I am checking the error message, I am printing the error message. And that's what happening there. And after that, if it is success, I am calling the function. If it is success, I am calling the function through pointer. We can't call directly in this case. I'm calling the function through pointer like this. We are calling it, and when my work is finished, I'm closing it. Uh, Now, I'm going to give you the time to ask if any doubts are there. So first, I'll clarify the doubts, and then we'll move to the next discussion. One student is asking, "Sir, what is the size of RAM?" One student is asking, "What is the size of RAM?" That you should know in your laptop what is the size of RAM. So different devices, different laptops or different desktops, different RAM size will be there. Listen. And one more question. Yesterday, one of the student mailed. I don't know the student is there or not. If it is there, type S. The student who mailed it. If it is there, please type S. Okay. So the student question is try to understand what he did is he created one executable file using that dynamic like linking concept. The executable file name is a.out, and this executable file is running in one terminal. And what he did is in another terminal he typed ldd a.out. His question is, when I type ldd a.out, why it is not showing libmno.so? Again, his question is, when you type ldd a.out, this program is already running here. Why it is not showing that libmno.so in that LDD. My question is, my answer is try to understand. This program is running here. When you type LDD a dot out, it will not show this a dot out dependency libraries. It will show this file dependency libraries, not the process dependency libraries. Now, one very simple understanding is when I type dot slash a dot out enter button, do you think that from the hard disk this a dot out is deleted and loaded into the RAM? From the hard disk, this a dot out is deleted or loaded into the RAM? Answer is no. Can I say one copy is loaded into the RAM? Can I say one copy is loaded into the RAM? In another terminal, when I type LDD a dot out, it will not show this a dot out, the copy a dot out dependencies. It will show this file a dot out dependencies. Got the point? R1, got the point? So this is called as a process. Anyway, we need to discuss what is the process and all other things. When your program is loaded into the RAM, when your program is loaded into the RAM for execution, it is called as a process. So for LDD command, you need to supply the file name. You need to supply the file name. So don't think that this a dot out is not the a dot out which is running in the RAM. This a dot out is nothing but the file name. That's why it will not show this library. That's why it will not show this library name there. One of your friend is asking, explain RTLD lazy flag, sir. Observe, to understand that RTLD lazy, just a minute. Suppose this is the hard disk. Suppose this is the RAM. Now what happens is normally nowadays modern operating systems, modern environment, in the hard disk, some portion acts as, in a hard disk, some portion acts as a virtual memory. In a hard disk, some portion acts as a virtual memory. Now you may get a doubt. So what is the need of virtual memory? The question is, now tell me, uh, can anybody tell me what is your hard disk size? Your in your laptop hard disk size? Can anybody? 1 TB, 500 GB. Similarly, can you tell me what is the RAM size? Similarly, can you tell me what is the RAM size? 4 GB. My question is, if this is 1 TB, this is 1 TB, why this is 4 GB only or 8 GB only? Can we increase the RAM size as we wish? As we wish, can we increase the RAM size? Physically, can we increase? No, because that depends upon the processor. I hope you may know that if it is a 64-bit processor, so the address bus will be, it can fetch 2 power 64 addresses. Getting the point? So, as you wish, you cannot increase the RAM size. How much you want, you can't increase the RAM size. So physically you can't increase the RAM size. The operating system designers, what they thought is, why can't we take the advantage of this space? Why can't we create a virtually some RAM? It looks like RAM, but it is not a physical RAM, it is a virtual RAM. So that is the concept behind this virtual RAM. You can't increase the RAM size as you wish. So when you use RTLD lazy flag, When you use RTLD lazy flag, what happens is the library which is present in the hard disk in one part, it will load it into virtual memory when you open it, when you open DL open. Getting the point? Who is asking the question? Are you getting the point? When you use RTLD lazy, then what happens is at the time of opening the library using the DL open, it is not directly loaded into the physical RAM, it is loaded into the virtual RAM. Later, when you use DL sim to get the symbol address, then only from here it is loaded. Otherwise, it is not loaded there. Even though you open it. Even though you open it. But when you use RTLD now, what happens is, at the time of opening the library only, it will go and sit into the physical RAM. At the time of opening the library only, it will go and sit into the, it will sit into the. One of your friend is asking difference between load time and RTLD now. Load time means you need to understand one concept here. Load time means when your executable file is loading, dot slash a dot out enter button. I'm not talking about library loading. When your executable file is loading, then the library is loaded. But here RTLD now or lazy, whatever it is, when you call DL open. Now will you agree when the DL open is called, already your program is present in the RAM? When this DL open function is called, when this DL open function is calling means, can I say your program is already loaded into the RAM? A7 got the difference? See, observe. One thing is to make you to understand in a simple way. This is the hard disk. In this hard disk, there is a.out file. There is a library, libmno.so. Now tell me, on the command prompt, when you write dot slash a.out, when the command prompt, when I write dot slash a.out, enter button, this a.out is loaded into the RAM. That is called a load time. Your executable file, when it is loaded, that is called as a load time. Is this point is clear? G7. What is the meaning of load time? Means when your executable file is loaded into the RAM for execution, it is called as a load time. G7. Is it clear? This point is clear. Up to this point is clear. I'm waiting for G7 answer. Up to this point is clear. What is the meaning of load time? Means when your executable file is loaded into the RAM for execution, that is called as a load time. Okay. Now, whatever the mechanism we are discussing here, this is a runtime binding. What is the meaning of runtime binding means? What is the meaning of runtime binding means? When your program is loaded, when your executable file is loaded into the RAM, this library is not loaded. When this executable file is loaded, this library is not loaded into the RAM at the same time. Getting this point? G7. Runtime binding concept means when your executable file is loaded into the RAM, this library is not loaded. Is that point is clear? When your executable file is loaded into the RAM, this library is not loaded. You need to respond fast? G7. When this executable file is loaded, this library is not loaded. If you don't reply it, I will not further move it. G7, try to understand. Otherwise, I need to skip your questions. When this executable file is loaded, this library is not loaded. How can I know that? How can I know that this executable file required how many dependencies? How can I know that this executable file required how many dependencies? LDD command. LDD command. And when you type LDD command for this program, you will observe only those three libraries. In that three, first one and third one is the OS, second one is the libc data. So, but this library you will not observe in this list. Means this library is not loading when your ADATOUT is loading into the RAM. Means this library is not loading when the ADATOUT is loaded into the RAM. Now the question arises, sir, then when this library is loaded? That is when your program is running. When your program is running, at the time depends upon your option. Depends upon your option that library is loaded. Your program is running, then if option is 1, if that if condition is true, then only it is loaded. If condition is true, then only it is loaded. Your program is already loaded, already running. Your ADATOUT is already running. And also when you use this flag, what is that flag? RTLD. When you use this flag, when the line number 12 is executing, when you use that flag, when line number 12 is executing, is it loaded into the physical RAM or is it loaded into the virtual RAM? Can anybody answer it? When line number 12 is executing, when you use RTLD lazy, is it loaded into the physical RAM or virtual RAM? Virtual RAM. That's what I'm saying. From virtual RAM, when it is again goes to the physical RAM, from virtual RAM, when again goes to the physical RAM, when you use DL SIM, correct. When you use DL SIM, then only it is. Okay then. Any other questions? One of your friend, the G7 is again asking the question. I can't think virtual RAM. Virtual RAM is a part of the hard disk. It will act as a physical RAM. Virtual RAM is a part of the hard disk. It will act as a physical RAM. In hard disk, virtual RAM is present, correct. P14, correct. In a hard disk only the virtual RAM is present. At the time of booting only, when your operating system is booting, at that time only some portion is reserved for this virtual RAM. Some portion is reserved for virtual RAM. Because physically you can't increase the RAM size. If you want to increase the RAM size physically, will you agree the entire hardware architecture need to be changed? Again, physically you can't increase the RAM size. If you want to increase the RAM size physically, entire architecture is going to change, the hardware architecture. Copy is done while virtual. It is copy only. T2 is asking one question, sir. When we use DL sim, from here a copy is loaded, again total is loaded. Again, my answer is one copy is loaded. Now here the concept of paging, segments, there are so many things are there. At this stage, I should not discuss that. Anybody heard about the term called pages? Anybody heard about the segments? Anybody heard about MMU, memory management unit? It will convert the logical address into the physical address. What is a logical address? What is a physical address? This is not the time to discuss. When the time comes in operating system concept, we'll discuss that. One of your friend is asking, RAM is extendable up to 16 GB. What is the meaning means? Your processor is having the capacity to access the 16 GB RAM, but you may inserted only 8 GB of RAM. Maybe whatever it is. So those things I should not enter into. I should not entertain the answers right now. But when the time comes, we'll see that. But any related things like dynamic runtime linking, DL open, DL, we'll see that. Those answers. My question is compile time, load time, runtime. In which time uh, the program executes faster? Means I am calling one function. I am calling one function. So, so in which time that function execution function call is done very fast? Answer is compile time and a load time. A runtime, it will take some extra efforts to find out the function address, right? Will you agree? A runtime, it will take some extra efforts to find out. Little bit slow. Why? Because you need to open the library, you need to ask the DL sim, you need to ask the DL sim to which function address you need. DL sim need to search, DL sim need to find out, it need to give you, then only you can call. So in this way, can I say runtime binding is little bit slower compared to the load time binding and compile time binding. S16 is asking one question, sir, header file DLFCN. See, as all of you know, what is that header file contains? What is that header file contains? We'll agree header file contains the predefined function declarations. Now, can you tell me DLFCN function contains which function declarations? Can you tell me DLFCN function, DLFCN.h contains which function declarations? DL open, DL sim, DL close, DL error, like this. So before entering into the new concept, my intention is let it be a time taking process. Please, if you have any doubts regarding this, because the next sessions are entirely the new concept, operating system concepts. There the programming theory, visualization is more in that. Now tell me, in which libraries, if you use the if you're designing any application, by using which library you can fix the bugs easily, you can enhance, you can improve the what you call, you can add some additional features. dynamic library. One of your friend question is, sir, when .so file, when it is generated? Can anybody answer your friend question? Your friend question is, when the .so file is generated. When the .so file is generated, when you write cc hyphen shared, when you use this command, I'll show you. When you use this command, then .so file is created. When you use this command, which command, where it is? Yes. When you use this command, then .so file is created. Got the answer? When we create a dynamic library, correct? When we create a dynamic library, .so file is created. If no doubt is there, we'll further move it. If any doubt, let me know. What is the advantage of dynamic runtime linking? If I ask you, what is the advantage of dynamic runtime linking and what is the disadvantage? What is the advantage of dynamic runtime linking and what is the disadvantage? Anybody can? I'll put this messages as a everyone for the time being. Everyone can see these messages, right? Others messages. Advantage is space is saved. Advantage is reduce the executable file size. Advantage is memory space. Disadvantage is speed is reduced. Correct? Whatever the answers I am getting is correct. I hope everyone can see, right? Speed is slow, correct? Because if you want to call the function, first you need to take the help of DLSim to ask the function address. Once the DLSim gives the function address, then only we can call. So I kept everyone public. The message is I kept public. Everyone can't see. We can't see. And when you're sending, don't send to me. Send to everyone. When you're sending the message, don't send to. You can't see. Now I think we can. Now send it to everyone, then you can. Everyone now you can see. Only for today. Only for this things. So advantage of a dynamic runtime linking is space. Why? Because when your a.out is loaded, once again I'm saying, suppose I designed one application. Suppose I designed one application. My executable file name is a.out. This application need 10 dependencies. So when this a.out is loaded into the RAM, if 10 dependency libraries are also loaded into the RAM, when my a.out is loaded into the RAM, if 10 dependency libraries are also loaded into the RAM, then what happens is unnecessary RAM space gets structured, wasted. Because we are not going to call all the functions at a time which are present in these 10 libraries. To effective way of utilizing of memory, what I can do is I can go for runtime. Now I think speed is not a matter. Nowadays environment, speed is not a matter. because of high speed processing capacities. Our processors are having high speed, so that speed will not affect a lot at current environment. Will you agree? Quad core processors, octa core processors are came, so speed is not that much issue in this case. Issue is only with a space. So to utilize the RAM space effectively, we need to go for this. Okay, then. So let's start with another concept. What is the concept name? So the concept name I told you, OS concepts with Linux, operating system concepts with Linux environment. In this concept, in this topic, this is the main top. That is the module name. We can call operating system concepts with Linux environment, or we can call Linux system programming, or sometimes it is called as Linux internals. Again, operating system concepts with Linux environment, or Linux system programming, or it is called as a Linux internals. So in this Linux internals, what we are going to discuss is the main topics are, in this Linux internals, we are going to discuss process and process management. Means what is a process and what is the multiprocessing, what is the hardware multiprocessing, what is the software multiprocessing, and some of the technical terms like what you call response time, turnaround time, throughput, wait time, like this. And some of the policies like round robin scheduling policy, priority based scheduling policy, FIFO based scheduling policy. So like this, some policies. Apart from that, there are some terms called context switching. There are some terms called PCB, process control block. There are long-term scheduler, short-term scheduler, like this. Apart from that, there are so many programs. So orphan process, zombie process, daemon processes, like this. There are some system calls we need to discuss. There are so many things we need to discuss about this process and process management. And one thing, to understand the remaining concepts which I mentioned after this process and process management, to understand the remaining concepts, this is very, very, very important. If we able to visualize these things, if we able to understand this remaining signal handling, file management, IPCs, process synchronization, remaining things are very easy. So this is very important part in this course, in this module, process and process management. Next, we need to understand the signal handling. You might have heard about interrupts. Have you heard the term interrupts? In a microprocessor or microcontroller point of view, it is called as an interrupt. But operating system point of view, it is called as a signal. When I'm talking about errors, I might have told you who will runtime errors. Who will generate a runtime error? Who will generate a runtime error? Segmentation fault or floating point exception. Who will generate? OS. That technically it is called as a signal. I might have told you on the day there are 64 signals are there. How to handle the signals? Have you heard the term called ISR, interrupt service routine? So how to handle the signals? There are so many things that we need to discuss programmatically. After the signal handling, we need to start working on file and file management. In our Linux, how many types of files are there? So what you called regular file, directory file, link file, pipe file, character special file, socket file, like this file concepts we need to discuss it. And in this we need to implement our own ls command also. In this discussion only we need to implement our own ls command. After we need to discuss a very important concept called IPC mechanisms. Some of those who already know about this, you may know that inter-process communication, how the processes can communicate between each other. That is an inter-process communication. Here we need to talk about a pipe mechanism. We need to talk about a named pipe mechanism. We need to talk about a message queue. We need to talk about a shared memory. That we need to discuss here. Not only theory, programs we need to. Our focus will be again programs only. We are entering into another level of programming that is called as a system programming. Whatever we are going to write a program using the C language we are going to learn. So IPCs is very, very important in a industry, in a interview point of view also. In this IPCs, we need to talk about a pipe, named pipe, message queue, shared memory, like this. After that, one very important thing we need to discuss it here, process synchronization using the semaphore. Using the semaphore concept, how to synchronize the processes, and what is the semaphore, what is the binary semaphore, what is the counting semaphore, what is the mutex, what is the deadlock situation, how to handle the deadlock situation, all the things programmatically we need to discuss it. After that we need to discuss another concept called thread and multi-threading. What is the thread? What is the difference between the process and thread? What is the advantage of the thread? What is the disadvantage of the thread? How to create a thread? How to synchronize the thread using the mutex? Like this we need to discuss it. After that, memory management we need to discuss. In this we need to discuss about a physical RAM, virtual RAM, MMU, logical address, physical address, demand page, page fault, what you called, how it is going to be converted, page in, page out, like this. There are so many things we need to discuss. This is only theoretically. Remaining things program is involved, but last whatever the chapter is there, you can consider as this chapter. This is a theoretical memory management. How the page is loaded, how the offset is calculated, what is a like what you called page table, like this. There are so many things we need to discuss about these things. Yeah, segment pages, segment, demand page, like this. So many things are there. I hope all of you are getting these points. This is the main topics in this module. These are the main topics in this module. Shell scripting is also there. Shell scripting is also there, but shell scripting I'm not going to discuss it. Anyway, you know the C program. Other faculty is going to discuss about the shell scripting. We'll see that. And pre-requirements. So before starting with that, what you called Linux system programming, few things you should know. The pre-requirements you should know. What is that pre-requirements is? First is you need to understand what is an OS. First important point is you need to understand what is the OS. Second important point is why operating system in an embedded system. Second point you need to understand why OS in embedded systems. In embedded systems, so what is the need of operating system? Why embedded engineers should have the knowledge of operating system, that you need to understand. Third is why especially Linux OS. What is the speciality of the Linux? What is the advantage of the Linux? Fourth is we need to understand what are the components of operating system. Fourth is we need to understand what are the components of operating system. Fifth is we need to understand the booting steps of OS. Now here what we are going to discuss is when you switch on the system till the login screen comes, will you agree it will take time? Again, for example, when you switch on the system laptop, so till the login screen comes, will you agree it will take some time? So in that time, what happening background, that is called as a booting steps. how your OS is going to be booted, what are the technical terms, what is the first step, what is the second step, what is the third step. Yes, that is called as a boot up time. So those steps we need to understand. So before starting with this process and process management, before starting with the process and process management, you need to understand in a simple way: one, two, three, four, five. Uh, S16 is asking one question. In C, boot concept is there. Why booting is necessary? I don't know what's your question. Very simple. When you switch on your mobile, will you agree it will take some time to operate it? It will take some time to operate it, S16. So at that time, inside some work is going on. That work is called as booting, loading, whatever it is. That also we need to, in a simple way, we need to understand, not in detailed things. Now, first thing, what is an OS? Point number one, what is an OS? My question is very straightforward question. Is it a OS is a hardware, or is it OS is a software? Again, what is an OS? OS is a hardware, or is it a software? Software. Now, can you tell me some of the devices which is connected to your laptop? Some of the devices, some of the hardwares which are present in your laptop? Yes. Keyboard, mouse, inside also. I am not talking about external devices. Inside also. RAM will be there. Hard disk will be there. Can I say microprocessor is there? Huh? Headphone is there. And webcam is there. Wi-Fi module is there. Graphical card is there. I will agree. These are the hardwares. Will you accept all these are hardwares? All these are hardwares. Bluetooth device will be there. All these are the hardwares. Ethernet module will be there. All these are the hardwares. So to manage this hardware, there should be one master will be there on the top of this. To manage all this hardware, technically it is called as a resources. To manage all these resources, will agree there should be one master. There should be one person should be available so that they can manage all this. Like in a company, HR. In any company, there is a term called HR. Manage all the resources. Will agree. Similarly, with respect to operating system point of view, to manage all these hardwares, I should not use the term hardware here. I need to use the term called resources. To manage this resource, somebody is required. That somebody is nothing but an OS. That somebody is nothing but a OS. OS is not a hardware again. Just now you told. OS is not a hardware. OS is a software which is managing all these resources. Operating system is a resource manager. Operating system is a resource allocator. Now, logically you think when you purchase a new laptop, can you use that laptop without an operating system? No matter what operating system, that is secondary. Can you use that laptop without an operating system? No. Now, when you purchase a desktop, so can you use an desktop without an OS? No. Now, can I say OS is a heart of this your laptop or desktop? And what is the benefit of OS? I can say OS is a resource manager which is managing the resources. One thing I need to ask you, what is the difference between the old Nokia 1100 nowadays smartphones? What is the difference between the old Nokia 1100? What is a Nokia 1100 and nowadays smartphones? Can I say nowadays smartphones I can do multitasking? Nowadays smartphones I can do multitasking. Hmm? Multiple works I can do it. And nowadays in a smartphones, one resource can be used for different purposes. Like if you take an example of camera. Now tell me what is the intention when the camera came? Can I say camera is useful for taking the pictures, photos? Yes. Now can I say now camera is used as a barcode scanner? Can I say now the camera is used as a gesture sensor? Now tell me, if you want to pay online, you went to any shop, nearest shop, so you want to pay online, what you will do? Maybe in Google Pay or maybe whatever it is. Yeah, barcode you'll need to scan it. For scanning that barcode, which hardware you are using in that application, which hardware you are using in that device camera. Now what I means to say you that when operating system is there, when operating system is there, so one device can be used for multiple purposes. Now tell me, in your Wi-Fi is there, in your mobile phone Wi-Fi is there, Wi-Fi connectivity, you can connect to a router wireless. Yes. What is the use of this Wi-Fi? You can connect to the router through, you can access the internet. Will you agree? But that Wi-Fi device can be used for something else also. That Wi-Fi device can be used for something else also. Answer is yes. Assume that you have one file, you want to transfer that file to your friend nearby you. So what you'll do? You will transfer it through that. Will you agree? Transferring the data through IR or through RF or through Zigbee, compared to this, you can transfer the data fast using the Wi-Fi. Gaming purpose also you can use. But one question arises in our mind: how I am able to do all these things using a small device called mobile phone? How I am able to do all these things using the device called mobile phone? Now you may know that why it is called as a smartphones. Previous phones just for only for calling purpose, only for uh, SMS purpose, and only two games will be there. I don't know, in a Nokia 1100, if somebody is still having that phone, only 2 3 games will be there. Yes, Snake and some cricket something. But nowadays smartphones, you tell me, today morning you might have installed one. Today morning you might have installed one game. Once you get bored, PUBG. Once you get bored, G7. So you concentrate on the subject, don't concentrate on the games. So when I type when I say the game, G7 is saying that sir PUBG. Hmm. So that's why you are unable to. That's why you are unable to like link these classes. Try to reduce that gaming. That's why you are asking lots of questions. Okay, okay, no problem. Just I am kidding it. Don't feel it. So what I mean is to say that because of this operating system is loaded on the top of the hardware, the entire scenario is changed. Will you agree? Entire scenario is changed. Nowadays, this mobile phone is becoming a part of our body, right? So how it is possible? How the camera can be used as a gesture sensor? How the camera can be used as a barcode scanner? But actually, the camera is designed for only for taking the picture. Now, can I say internally somebody is there who is managing these resources? Internally, somebody is there who is handling these resources. Now, who is that somebody? Who is that somebody? That somebody is nothing but a OS, correct? Operating system. Android is one of the Linux flavor. Android is one of the Linux flavor. I don't know. You may know it or not. Before this Android, so you may know like Windows phones are there. Windows OS phones, where yes, Symbian. So a little bit costlier that at that time. Will you agree? Little bit costlier at that time. But once the what you call Android came into picture, which is a free OS, the entire story is changed. Entire thing is changed because it is a free source code. If I have the capacity, I can download the Linux source code. I can create, I can assemble it, whatever the things are, I can use it. I can, yes, entire revolution is changed. And touch screen, just one more device is there in our mobile. We forgot that. Awesome. There are so many changes. How all these hardwares are managed? Who will manage all this hardware? How multiple things I can do? How multiprocessing I can? How multiprocessing can be done? I don't know. In a previous, yes, fingerprint sensor is there, correct? Fingerprint module is there. There are so many sensors are there. Now today's your work is in your mobile phone, whatever the mobile phone, go to search like Google it in where try to find out what are the hardwares are there, what are the sensors are there, what are the things are there. You can go to the specification, you can get it. You can go to the Amazon and you can search any mobile. There you can find out the specification, what are the sensors, what are the hardwares are there. You can. Is the task is clear? Minimum 10 to 15 I need. One of your friend is asking in a previous Nokia 1100, is the processor is present? Yes, definitely it is present. But on on the top of that, Java program is running. I don't know. In a previous days, when you're transferring the data through Bluetooth, you can't do any other work. Will you agree? In a previous old mobiles, when you're transferring the data through Bluetooth, you can't do any other work. Now you tell me in a smartphones. Now I can minimize that. I can do some other work. Assume that I given an appointment to somebody. So what I can do when I'm starting from my home, I can share my what you call it? Through WhatsApp. I can share my location. Awesome. So bank transactions you can do through mobile. Yes, live location. Bank transactions you can do. Purchases you can do. Whatever you want to purchase. Awesome. Oh, so many works you can't if you list out you and sit and list out what are the things I can do in your mobile. Open the home page and see what are the applications are there, what is the use of that application. Try to take in half an hour after the class and sit. At least you will get it minimum 20 to 30 works, tasks, jobs you can do using your mobile. Now some of you are listening the lecture through mobile, seeing the screen. So how it is possible? Only the thing is, only the thing is because of operating system. Operating system is a resource manager. Operating system is a resource allocator. All of you know that you might have faced this one. When I'm taking the lecture, will you agree my what you call my voice is coming through my mobile? Will you agree? My voice is coming through my mobile. Via? Can you tell me via? Which hardware? Via which hardware? Via which hardware? Via mic, earphones, whatever it is. Now suddenly when the call comes, what happens? Suddenly when the call comes, can I say this what you call Zoom app gets muted? Means one resource I can use for different purposes, disconnected. Like this, if you think, if you imagine, if you think it, there are so many works I can do. So so OS is nowadays in all the embedded products, operating system is becoming a common. All the embedded products operating system is becoming a common. I might have told you at the beginning days of our C, before at the when I started with the course. Previously, embedded system means a system which can perform one task, where hardware and software will be there. Nowadays, the embedded system is a system which can perform multitasking, where hardware is there, OS is there, on the top of the OS, applications are there. Will you agree? Again, when I started with the embedded system course, I might have told you on previous days, embedded system means which can perform only one task, only one while one can run. But nowadays, the embedded system is becoming a smarter. With one embedded device, I can perform multitasking. With one embedded device, I can perform multitasking. With one embedded device, we can perform a multitasking where multiple works I can do it. How it is possible? Answer is very simple. On the top of the hardware, one strong manager is there. That is nothing but a resource manager. That is nothing but an OS. So nowadays, all the embedded products, within a few days, every embedded product inbuilt becomes an OS. Inbuilt OS will be there. Yes, sir. In watches also embedded OS will be there. Smartwatch. Yes. In a first day, you asked which are embedded products in a classroom. Yes. Which are embedded products in a classroom? AC is an embedded product. Projector is an embedded product. My system is an embedded product. Nowadays, I mean, you may know it or not. Smart ACs are coming. You can control your AC through your mobile phone. OS also becoming what you call AC also becoming an IoT device. Internet of Things. Through internet, you can communicate. Like this, there are so many things. Plenty of the things are there where inside uh, OS is there. Routers are there. How many of you are using? I don't know how many of you are using the internet through Wi-Fi, through what you called this one, not mobile data. So routers will be there. Broadband, yes. Routers will be there. In that routers, OS will be there. Nowadays, smart bulbs are also coming. See, if you think like this, within a few days, yes, Alexa, yes, correct, T2, good. I think you have this Alexa device, right? T2. Hmm? No, okay, no problem. Okay. So just for to understand where this is there, just I'm taking this discussion. So I don't know you know it or not. To nowadays in smart printers, every printer is having one registered mail ID. If I send the mail to that registered mail ID, automatically the print will come. And the printers are connected to Wi-Fi also. Through mobile also, you can send a print command wireless also. No need to connect wired. Wireless also you can. Now, if we think like this, Every product is becoming OSs are present in cars. Yes. If you think like this, yes, self-driving cars like Tesla. If you think like this there is no end. And how it is becoming how it can become it becomes a multitasking means how it can perform one device can perform multiple works means only the answer is OS is there. One layer is there. Now tell me, in a Nokia 1100, can you install the new game? In a Nokia 1100, can you install the new game? No. But nowadays smartphones, yes. Now will you agree that the games which you are playing internally it may using so many sensors, accelerometer sensor, like what you called for assume that you are using the car race, playing the car game, whatever it is. Touch sensor. So what's your task today is, anyway today is Saturday, I'm going to wind up this session. What's your task today is, what are the hardware components are there in your, what are the hardware components are there in your smartphones? What is the purpose? Second is, using the smartphones, what are the works you can do it? Got the point? Hmm? Just for, it's not big task. This is actually, it is not a task. You can within 2 minutes you can sit and write it. It's clear. I hope you got S16. I'm very sorry. I don't know what is that. In old mobiles, one system is there for making a ringtone. That is some code is there. I don't know what is that. There you can ringtone code will be there. That is old memories, right? I don't know. Some of you may know it or not. Our own ringtone we can create in our old mobiles where uh, some procedure will be there. Okay, whatever it is. Anyway, I'll share this slide to you. I'll just a minute. I'll share this slide to you. Why Linux OS? Anyway, what are the components? All these things we need to discuss. What are the booting steps? All of you are observing BIOS, MBR, grub, kernel, init, run level. Share this PPT. Anyway, we are going to discuss this also step by step. After this only, we need to start with process and process management. After this only, we are going to start with process management. Thank you very much.